Hello gamers! For today's class we'll be looking at the popular series Pokemon.
Yes! Yeah!
We're also going to be talking about mathematical formulas. Not just in Pokemon, but in most action RPGs, attacks deal damage, which is usually depicted as a number. Today we're going to address how games determine that number, aka the damage formula. For Pokemon, the formula is already out there, so it's not that hard to find out. When most people talk about the formula, they talk about how to get the number. But I'm not here to just plug in some numbers and call it a day. I'm going to take an extra step and explain why Game Freak chose these specific numbers, and this specific formula. It's a lot of detective work trying to decipher a formula from scratch, but I am a bona fide veteran. I'm proud to say I've played a lot of Pokemon. My resume includes shiny farming, breeding for natures, and Pokemon battling in Showdown. This formula, while big and scary, can actually be simplified. What I mean is that I'm going to clean it up a bit so that it'll make it easier on the eyes. But before I do anything, first things first, everything after the two are all modifiers and situational. But what are modifiers? Modifiers are situations that boost or nerf the damage. However, we're focusing more on the general situation, where we are more reliant on the Pokemon stats like attack and defense. You won't always have a crit, super effective, a weather buff, and etc. They're also self-explanatory, like the damage doubles when it's super effective. So we're going to ignore the modifiers and focus more on the meat of the formula. What do these variables stand for? Well, these variables are what help determine the damage, and they change all the time depending on the Pokemon. There's A, which stands for the attacking stat, which is based on the attacking Pokemon's attack or special attack stat. There's D, which stands for the defending Pokemon's corresponding defensive stat. So if it's a physical attack, it's defense. If it's a special attack, it's special defense. There's the power of the attack, which I label as P. And finally, there's the attacking Pokemon's level, which I will label as L. Let's start cleaning it up. The first thing I notice, I can see the whole formula, but the plus 2 over here is divided by 50. My plan now is that I'm going to put these into parentheses and multiply it by 1 over 50 instead. For these variables, we can put it into one simple fraction, so it becomes PA over D. Great, it looks smaller and more compact. Oh, I just noticed something. There's a lot of 2's in this equation. I'm pretty sure this isn't a coincidence, so I'm going to use factorization. I'll divide everything by 2 and balance it out by multiplying the whole thing by 2 again. Now the equation looks like this. How about let's go a bit further. L over 5 is the same as 1 over 5 times L, or 0.2 times L, so let's change it to that. This 25 is looking a bit lonely, so I'll put it over there. This equation looks clean enough, I can work with this. When I want to break down why these numbers are here in the formula, I ask myself, what is the purpose of the equation? It's designed to calculate the damage, so what are the possibilities? What are the things I want to avoid? I'm going to dissect the formula one part at a time. There's this part with the level, the next part with the stats, and then there's the 2 all the way in the end. I'm going to approach the 2 first. Based on my experience, when it comes to Pokemon damage, there's an uncapped max damage. However, on the opposite end, the minimum damage is always 1, and this is important. This means the damage can't be a negative number, and it can't be 0. They designed the formula so that there is no way a Pokemon can get 0 or negative damage, and of course, this isn't including 0 times modifiers and abilities. So let's prove that statement. Let's say it was possible. The damage is equal to 0. If it doesn't work, this tells me that the damage can't even be 0, and if it can't even be as low as 0, there's no way it can be negative. Inputting it into the formula, then 0 is equal to all of this. Subtract 2 from both sides, and negative 2 is the product of this equation. Here's the thing, it's not possible. Recall the only way to get a negative number as a product, you need to multiply a negative number with a positive number. Level, power, attack, defense, they can only be positive. Thus it's not possible for the damage to be a negative number. That's why the 2 exists, to always have the damage to be at least 1. But why 2 specifically? This is actually due to the randomizer modifier. And what is the randomizer? It's actually a modifier that multiplies the end result of the damage by 0.85 to 1. This helps give a bit of variation when it comes to damage. I'm going to give you an example of a level 1 Shuckle using Constrict on a level 100 defensive Arceus. As you can see, there are 16 possible outcomes. 15 of them are 1, but only one of them is 2. Which is a crazy thought, to do even more than 1 damage to a god.
If you can make God bleed, then people will cease to believe in him.
However, this is actually strong evidence to prove why we need to add 2 at the end of the formula. I can conclude that the end result of the equation rounds down. Let's say we have 1 instead of 2. Then if we have anything less than 1, then boom, it rounds down to 0, and we can't have that. That's why it's 2, and in fact, that's why the whole thing is multiplied by 2. Now that we got that out of the way, I'm going to approach the more straightforward PA over D. It's pretty simple actually. Which has the bigger number, the better the effect. But I'm going to look at it more analytically. There are 3 possible scenarios. The attack is higher than the defense, the attack is lower than the defense, and the attack is equal to the defense. When the attack is higher, the damage goes up. When the defense is higher, the damage goes down. But the most interesting part is when the numerator and the denominator are equal. Or in other words, the attack stat is equal to its corresponding defensive stat. And when the numerator and denominator are equal, this means the fraction is equal to 1. Why is this important? Well, when you multiply the power, it tells you how much impact it has. But let's talk about the situation where the attack is equal to the defense and why it's a problem. Move's power can be as weak as Constrict's 10, and it can be as high as Explosion's 250, and this is including Z moves. And when you multiply it by 1, any attack could one-shot a low-level Pokemon. Like imagine using a level 5 Squirtle and using Surf, which has 90 power. As long as its special attack is higher than the special defense, it'll do at least 90 damage. That could one-shot most Pokemon up to level 30, and that's like half a Pokemon game. Then it's safe to assume that the first part of the problem exists, so it's used to counterbalance the high power damage like Explosion. Wait a second. Explosion is 250, and that looks really close to something. Aha! The 25. Recall that if the numerator and the denominator are the same, then it equals 1. So I'm going to multiply the level part by 10 over 10, just so I can get that sweet 250. It also doesn't change the formula. Think of it as multiplying by 10 and dividing by 10. I'll just move the 250 here again, to illustrate the Pokemon power is being balanced out. So when I think about dividing the power by 250, at most it'll be balanced at 1. But man, divided by 250, that's a lot of damage reduction. So I'm going to use some deductive work here. Using the Squirtle example, the reason why the power needs to be counterbalanced is because the HP is low in lower levels. So I suspect that the best way to approach this is by understanding the HP. And the best way to analyze the HP I figured was to look up 3 Pokemon with extremely close HP stats. Musharna, Entei, and Amoonguss, with a base health of 116, 115, and 114 respectively, with 436, 434, and 432 as the max HP, and 342, 340, and 338 in the minimum at level 100. So it's safe to assume that each base HP grants 2 health at level 100. I'm going to create an equation for HP using what I know. HP is equal to 2 times the base, and there's probably more to it than that. We'll call it X. Using the Musharna example, 342 is equal to 116 times 2 plus X. Doing some quick multiplication and subtraction, 110 is that X. That's very close to 100, the max level. And the last 10 is probably the minimum HP. Oh wait, we can prove that. I'm just going to go to Pokemon Showdown, and apparently there's a level 0. The minimum HP is 10, and applies to every Pokemon, with the exception of Shedinja. But that's great. That's probably where the 10 comes from in the formula. But, looking at it closely, their HP is different at level 50. 176, 175, 174, which is an HP gap of 1 instead of 2. But I'm not going to give up. If I had enough patience to play League of Legends, then this should be easy enough by comparison. I'm going to use the Musharna example to start it off. At level 50, the HP is 176, and at level 100, the HP is 342. The difference is 166 HP, and 50 levels. Wait a second, 166 minus 50 is equal to 116, which is the base HP for Musharna. Let's see if this applies the same to everyone else. It does. At this point, making an equation is like fitting pieces into a puzzle. So at level 50, HP equals B plus L plus 10. So at level 50, this part of the equation equals B. At level 100, this is equal to B but doubled. And the only thing that changed is 50 levels. I got it, BL over 50. So that when L is equal to 50, this is equal to B times 1. And when L is equal to 100, this is equal to B times 2. Now the HP to calculate the equation is BL over 50 plus L plus 10. Phew. Now for the final part. Looking back into the formula I rewrote, the only thing left is the 2L. but I honestly have no idea where that comes from. The equation is thinking in the perspective of the attacking Pokemon, not the defending Pokemon, so their base HP and level isn't exactly relevant in this equation. The two can come from anywhere. It can balance out the 2 HP per base that they get from level 100, or it could be because there are 2 L's in the HP equation. Okay, that reasoning was a bit desperate. I really can't come up with something. And that's okay. My logic was that these numbers existed to balance out the attacking and the defending Pokemon. And that's how I found out why Game Freak used these numbers and variables. And I'm really glad I got this far. And even if I got told this whole thing was just wrong, at least I tried. And that's it. These are what all the numbers stand for in the damage equations. Endnotes. If you ever wondered what it's like to learn upper levels of math, this was a good preview. It's more about the mindset and understanding how to problem solve. I used my own experience to test the limits of the equation, and with that, I came to the conclusion as to why these numbers appeared. It was as if I was the team that helped create the formula in the first place with Game Freak. And that's the Pokemon formula in a nutshell. If you like content like this and want to see more of it, please like and subscribe, and I'll see you next time.